Okay, so our quiz problem was basically to find the equation of this line, but we want to do this in several steps because we want to really understand what the line is. Okay, so the first thing I ask you to do is sketch a line through the points. Okay, now that doesn't mean just between the points, that means sketch a line that goes through the points. So, it comes all the way down to the x-axis, goes through the y-axis at some point. All right, so did okay with that. We could have extended the line a little further. Your graph ends at some point. You don't really need too much past the y-axis, but let's just see now. Okay, so then find the slope. Now, when you find the slope, I really recommend that you where'd my chalk go? Okay, I really recommend that you sketch it. Okay, so you've got a run and you've got a rise. And I really recommend that you make this picture. And then complete a triangle so you can see all this within a triangle. It just gives you a better feel for what you're doing. Now, what's the run? Well, the run goes from x equals 2 to x equals 6. Now we can sketch a couple of dotted lines here for the x coordinates. And right here, x equals 2, right here, x equals 6. We sketch a couple of lines for the y coordinates of these points. And this line appears to be y, well, it is y equals 4, and this line is y equals 6. Okay? Then we can easily see that the run goes from x equals 2 to x equals 6. How far is it from 2 to 6? Well, we do that in our heads. It's 4 units, and it's plus 4 units. And we get that by doing the subtraction. 6 minus 2 equals 4. The rise, well, y goes from 4 to 6 here. Y is 4 here, y is 6 here. So the rise is 6 minus 4. Oops. I got 6 in my head. He wrote it down here, but that's wrong. Y is 7 at this point. Okay, so the rise is, x goes from 4 to 7. The rise is then 7 minus 4, which is 3. So the slope is rise divided by run, which is 3/4. I conventionally like to put 3/4 here with a box around it, the box indicating this isn't a length, it's a slope. Right along the sloping line. Gives you a complete picture of the slope between these 2 points. All right, so we find the slope. Now you can also find the slope using slope formula y2 minus y1 over x2 minus x1, which is 7 minus 4 over 6 minus 2, which is 3/4. It's okay to use the formula, but you want to understand what the formula means. Why did we do y2 minus y1? Well, the rise is 7 minus 4. You don't need a formula to see that. It goes from, y goes from 4 to 7. So y2 minus y1 is 3, and you don't even need the formula, but it's good to know the formula to keep yourself honest, okay? You should know the formula, and ideally, you know the picture so you know what the graph is telling you. Not just a bunch of formulas, but some actual tangible quantities. So I urge you to know the formula, certainly, but know what it means and be able to draw this triangle and confirm the formula. Ideally, you find the slope both ways so you really totally understand it. Okay, now we want to estimate the y-intercept. This is where we ran into a little bit of trouble. What's the y-intercept? Well, the y-intercept is the point where the line meets the y-axis. Where does this line come together with the y-axis? Well, it comes together here. Now, can we estimate the coordinate of that point, the y-coordinate? You know that x is 0 because on the y-axis, the x-coordinate is 0. Okay, so we have 0. What's the y-coordinate? Well, 0 is here, 4 is here. So I could divide this in half, and I'd see that 2 is about here. So this would be y equals 2, y equals 3, y equals 1. So we could even put numbers here. Here's 1, here's 2, here's 3, here's 4. Be a little bit clumsy to put those numbers into this picture. It would kind of obscure the picture. But we should understand. This is 4, this is 2, cut that in half, this is 1, and then 3 is the same distance above 2 as 1 is above 0, for example. Okay, so we estimate the y-coordinate here. It's closer to 2 than it is to 3. So I'm going to estimate it's 0, 2.3. Okay, does that make sense? Reasonable estimate? Okay, now we want to write an equation based on our estimate. It's not going to be the accurate equation because it's based on an estimate, but by estimating, we gain insight into what all this means. And that way, if we get into the middle of a problem and kind of forget a formula or something like that, we can always estimate it and maybe remind ourselves what's going on. Okay. So the equation. Based on the estimate, y equals mx plus b. There's our slope-intercept form. Why would we use slope-intercept form? Because we've calculated the slope and we've estimated the y-intercept. Okay, this would be our value of b. That's where the graph crosses the y-axis. So you get y equals 3/4 x plus 2.3. Now that's an estimate, so I'm going to put a little wavy line above the equal sign to show that that's approximate. Now there are several things we could do with this. One thing I was going to ask you to do is like plug 6 in to this equation. If you plug x equals 6, 3/4 of 6 is 4.5. And if you add 2.3, you get 6.8, which is real close to 7, but not exact, okay? So I'm going to add a little something here. And, you know, I've been missing my chalk. I changed my pants last time. I found 2 pieces of good chalk in the pocket. I don't know when I would ever put the chalk in my pocket, but I apparently did. Okay, so we check the estimate. If x equals 6, is y equals 7. Well, if we plug in x equals 6, and do the arithmetic, we get y equals 6.8. So this equation based on an estimate would tell us that when x equals 6, y should be 6.8, when it really should be 7. Still, that's close. Not exact, but it's close. And that's going to be useful now when we find the equation. Now, people in class did a pretty good job of finding the equation. So there's a process that we use to actually find this equation. And leave that there. Better camera angle. Okay, so all this is what we get from drawing the picture and making an estimate and calculating the slope. Know that m is 3/4, so y equals 3/4 x plus b. And everybody got to this point. Now I kind of intervened because we needed to move on a little bit, but that's very good. All that remains is pick either of these points. We know an x value and a y value. Okay. So we plug in x, y from one point. Okay, make a quick choice. Everybody point right if you want this one, left if you want this one. Which way you want to go? Doesn't matter. Okay, we're going left. So we're going to use the point 2, 4. Pick the first answer I saw. If we use 2, 4, what do we get? We get y equals 4. And x equals 2. So we plug those numbers in. And we have an equation we can easily solve for b. Doing the arithmetic, you get 4 equals, actually, I'm not going to do it this way. You can do it any way you want, as long as you get it right. But the easiest way to solve this problem is to multiply both sides by the common denominator 4, which removes all denominators and removes fractions from the equation. So we're going to say, okay, 4 times 4 equals 4 multiplied by 3/4 of 2. Okay, I think we can easily understand it. 3/4 of 2 is 6. So I just want to put 6 there mainly because I'm running out of room. And I don't really like the way that's written, and I do apologize. Let me write this out so it's really clear. Okay, so y equals 4 times 6/4 plus b. Now, of course, the 6/4 could have been reduced to 3/2, but since we're multiplying both sides by 4, before we reduce the fraction, this is what we're going to do. Okay, so 4 times 4 is 16, and that's 4 times 6/4 plus 4 times b. So 16 equals what? The 4 here is divided by the 4 here, leaving us 6 plus 4b. So we have 16 minus 6 equals 6 plus 4b minus 6. And 6 minus 6 is 0, so we end up with 10 equals 4b. Don't have room to write out all the details of the last step, but we're pretty good with solving linear equations. So we divide both sides by 4. So B is 10/4, which is 5/2, which of course equals 2.5. Well, now we know what number to substitute for B. You plug in 2.5 for B or 5/2, and we get the equation. And what are we going to get? Okay, well, we take this 2.5, and I'll use 2.5. That's our value of B. So we're going to bring that back up here and plug it in for B. And we get y equals 3/4 x plus 2.5. Then we kind of check it. We plug in x equals 6 the same way we did here, but instead we're going to have a 2.5. And when we do the arithmetic, we get 7, which is exactly what we should get. So that's the check process that we want to use when we get the problem done. Make sure we've done it right and to reinforce everything else we've done. Now, I don't have room in the check. We plug in x equals 6 here and see if we get y equals 7. And we do. 3/4 of 6 is 4.5. We add 2.5, we get 7. So that's the process of finding the equation of a straight line if we know 2 points. And the homework looked fairly good on this. There were some errors, but I had some problems that just kind of went haywire. But yeah, I think kind of the majority of problems were pretty good when you're given 2 points. Try to expand it to where you can do all this. It'll give you much deeper insight. Another exercise that we want to do is find the equation of a line through the point 4, 8, with slope negative. I'll just use an integer, -3. Okay. So how are we going to do this? Hang on a second. Okay, now the process now is very straightforward. We substitute -3 for m. The recording? Yeah. Okay. Substitute -3 for m. Make it look a little more like an m. And you get y equals -3x plus b. Now that's kind of equivalent to what we had here. We found that the slope is 3/4, doing the process for the slope, which is really pretty straightforward if you've got 2 points. Okay, so we plug in for the slope. And now we have this, but now we know X and Y. We plug in X and Y from one point. Now over here, you have 2 points to choose from, and it didn't matter which one you choose. You're going to get the right equation if you do the arithmetic right. I'm watching the camera here, and there's some bizarre things, but I think we're okay. So substitute for xy using xy equals 4a. That's the only point you've got. Over here, you had 2 points to choose from, as I said. It didn't matter which one you chose, you were going to get the same thing in the arithmetic, right? Okay, so now what this means is, here we've got y. Here's your equation. Here's y. Okay. Instead of y, you're going to write out 8. Okay. And then you're going to write out everything else until you get up to x. I'm going to write it out just in order. There's an equal sign, a negative, a 3, and now there's x. And x is multiplied by the negative 3. So I'm going to put that in parentheses, and I use parentheses as opposed to a dot because parentheses are easier to see. But you could write negative 3 dot 4 if you wanted to. And then we write out the rest of the equation plus b. So everything is in the equation except that y has been replaced by 8 and x has been replaced by 4. Now that step is a little bit of a hang up for some people, so make very sure that you got that step down. Okay, well then we just do the arithmetic. I'll just go back to white chalk here. We get 8 equals negative 12 plus b. We add 12 to both sides. 8 plus 12 equals negative 12 plus b plus 12. So that b is 20. Now I switch sides here, but clearly this side gives you b plus 0. That's just b. And this side gives you 20. So you have 20 equals b. And I write that as b equals 20. We can take that 20 and we have the equation y equals negative 3x plus b. So that's what we're going to use up here. But it becomes y equals negative 3x plus 20. And just to be really clear, this is after substituting 20 for b. Okay. The big thing here is, I told you that the line is perpendicular to this line. That means that you know what its slope is, provided you know that the slope of a line perpendicular to the other line is the negative reciprocal of the slope. Okay, so big deal. Slope of a perpendicular line is a negative reciprocal of the slope of the original line. Also, the slope of a parallel line, lines are parallel if they have the same slope. Okay, that's somehow the parallel thing for a lot of people in the class didn't. A lot of people, at least a few people, didn't pick up on that, but they picked up perfectly well on the perpendicular. Okay, so I'll also note that slopes of parallel lines are equal. Okay, I got these in red. You got to know those things. Well, we're picking up on this question here. Okay. Can't see anything. The screen keeps freezing up. Okay. And for the perpendicular line, the slope is the reciprocal of this slope, which would be 1 over -3, but it's the negative reciprocal, okay? And the negative reciprocal is positive 1/3. Okay. So for the perpendicular line, and this symbol means perpendicular. Everybody should be familiar with that, but just in case, that means perpendicular, okay? So the perpendicular line, y equals 1/3 x plus b. So we're trying to find m and b. We easily find the slope if we know this equation of this line. It's the negative reciprocal of the slope. And now if you have a point on the line, you know x and y, and you just plug in. Now, without going into complete detail, without writing out all the details, I'm just going to say since 5 minus 2 is on the new line, we get -2 equals 1/3 x, well, 1/3 of 5, sorry. Plus b. Now, rather than working with fractions, I solved the equation. I'm just going to do the solution. I'm not going to stop and explain every detail because we've done it on this. When we multiplied, actually, on the one before that, we multiplied both sides by 4 in the first problem. We're going to multiply both sides by 3 because that's going to clear out the denominator and we won't have fractions left. And as before, 1/3 of 5 is 5/3. gives us -6 equals 5 plus b. So that -6 minus 5 equals 5 plus b minus 5. Very easy equation to solve if you remember to multiply through by, oh man. Illustrating all the pitfalls by falling into them. Okay. I got hung up on correcting the 5/3, and then I wrote this down carelessly. I didn't multiply 3 by the entire right-hand side, did I? So we got to put 3 parentheses around the entire right-hand side and then do the arithmetic. We get -6 equals 3 times 5/3 plus 3 times b. Now, the 3's divide, we get -6 equals 5 plus 3b. -6 minus 5 equals 5 plus 3b minus 5. Everybody should be familiar with these steps by this point. So you get -11 equals 3b. Model room, so I have to continue in a new column. So I could write this as 3b equals -11. Divide both sides by 3, and I get b equals -11/3. So that y equals 1/3 x plus b becomes y equals 1/3 x minus 11/3. We can then check this because, as usual, never all that confident that I wrote all the algebra out correctly. I can be careless, miss a step one trying to explain another one. Okay, so if x equals 5, does y equal -2? Well, if x is 5, we have 5/3 x minus 11/3, which is -6/3, which is -2. This checks. I'm not going to write out the check, but actually the check is simple. I'm going to write it out. X is 5, not -2. I'm just writing these steps out. We plug in x equals 5 and see if we get y equals -2. We plug in x equals 5, then x becomes 5. We get this equation. So y is 5/3 minus 11/3. So y is -6/3, which is -2. Of course, you've got to do the fraction calculation correctly, but I'm not going to go back and explain that. If you're not clear why you get -6/3, review the addition of fractions. You got the same denominator. You can just add the numerators. 5 and -11 gives you -6. Okay. Okay, well, the line parallel to y equals negative 3x plus 20 through the 0.5 negative 2. In other words, it's a line through the same point as this one. And let me sketch that line. Now, this is the line y equals negative 3x plus 20. Not a very good depiction of the line. It's not steep enough, should be steeper, but at least we have a schematic. And then we have the point 5 negative 2. So this is the point on 4, 8. And here's the point 5 negative 2. And this line is supposed to be perpendicular. I mean, it makes a right angle with this line. And this is the line we found here. Y equals 1/3 x minus 11/3. Now, the graph isn't correctly drawn. Okay, negative 11/3 is not even quite negative 4. That's 8. That looks like it's about negative 6 instead of negative 4. Should be up higher. This line should be steeper. Actually, this line should be steeper and this line should be less steep, but we're not going to worry about that. We know how to graph lines. We can always construct an accurate graph using slope-intercept formula, using the x and the y-intercepts, okay? Because we can easily solve either of these equations for the x or the y-intercept. Well, that's not what we want to do right now. We want to see the idea that we have a line here that's perpendicular to a line here. And we're going to find that this line is 1/3 x minus 11/3. It goes through this point. It's perpendicular to this line, meaning that it has a slope. It's the negative reciprocal. And we found that line here using all that. Now what we want is we want a line parallel to this line. It goes through the 0.5 negative 2. Now what's that line going to look like? Again, don't take the graph seriously to scale or anything, but this is pretty much what it looks like. Okay. Or the picture. Okay. Its slope is the same. They have the same slope, they're parallel. Okay. So the line's parallel, so m equals 3 for the new line. The line parallel to this line through this point. Well, m equals negative 3. The point is 5 negative 2. Well, at this point, with a little practice, it's very easy to find the equation. M is negative 3, so y equals mx plus b becomes y equals negative 3x plus b. And x is 5, y is negative 2. We plug in 5 for x. We plug in negative 2 for y, and we just solve for b. Same thing we did before, so I'm not going to go through all the details of it. But it's the same process that we used here. Once we found the slope and know a point, we solve for b. And then if b is 13, well, the new line is y equals negative 3x plus b because it's mx plus b. M is negative 3, b is 13. There's your y equals mx plus b. So this line is y equals negative 3x plus 13. Now, if you were to estimate the y-intercept of this graph, you'd only get something like 10 or maybe 11. You're not going to get 13. If you estimate the y-intercept of this graph, you might get 16 or so. You're not going to get 20 because the line isn't steep enough. So don't take the scale of this thing, don't take this as a serious scaled graph for the three lines. But this shows you what's going on. This line is perpendicular to this one, so its slope is 1/3 if the slope of this one is -3. This line is parallel to this line, so its slope is the same as the slope of this line, -3. But we have different points. Using those different points, we find a different value of b, and we get the equation of the line. Now, what I'm going to find is, what are the coordinates of this point? What point do I mean? I mean this point that I'm circling or Xing in purple. The point where the graph of y equals -3x plus 20 crosses the graph of y equals 1/3 x minus 11/3. Okay. So can we see everything? At the crossing point, y equals -3x plus 20. Okay, whatever the coordinates of this point are, they have to satisfy this equation. And y equals 1/3 x minus 11/3. And again, this just says that the x and y coordinates, whatever they are at this point, have to satisfy both equations. The point is on this line, so it satisfies this equation. The point is on this line, so it satisfies this equation. Well, we conclude but we can make an estimate. Okay, it's not a very good estimate. We estimate let's see, if this is 4, and this should be 8, and if this is -2, that should be maybe -1. Two C's there, boy, I thought I'd written both down. If we plug 8 and -1 into this equation, -1 equals -3 times 8 plus 20. That makes sense? Just plugging in the 8 and the 1 into this equation. Now, is that a true statement? Well, not quite, because if you do the arithmetic, this gives you -1 equals -4. This is an arrow, not an equal sign. It's got like an arrowhead on it. I'll make it even a little longer. Okay. That means that if this equation becomes -1 equals -4. Okay. So it's not really true. But given that this graph should have been turned this way a little more, it's not too bad. Second equation is -1 equals 1/3 of 8 minus 11/3. You know, I'm looking at that and thinking that just about works out. I'm pretty sure that works out. So we get -1 equals 8/3 minus 11/3, which is minus 3/3, which equals -1. So we get -1 equals -1. Okay. This is close. This one is, well, we nailed it. This is true. This isn't quite true. Okay. So what we conclude is this point 8, -1 actually lies on this graph because it satisfies this equation. It doesn't quite lie on this graph, although it's maybe kind of close. So if we draw a more careful picture of these equations, we can estimate what the crossing point is. Okay. So that's really the subject of the next assignment. I think I've got to do tonight. I might move it a day later because I'm not sure there's any good reason it should be due tonight. I don't have anything due tomorrow. Okay. So I'm going to stop and check that before I forget. Okay, so I just realized we're pretty much out of time. So our procedure for estimating the crossing point of two graphs is graph them and estimate. Okay. We call this a set of simultaneous equations. Graph the two equations and make an estimate. So I'm going to just leave you with these words. Okay, to find a solution to a set of two equations, graph both equations and estimate the crossing point of the graph. Okay, so if you can graph the equations and see where they cross, you've got it. And then check, see how close you are.